Okay, let's talk about impulse. Impulse is the quantity, force, and time together, and there's both linear impulse and also rotational impulse. So let's talk about both of them. First of all, real quick look at the units for force. Well, again, in the English system, we know force is in pounds and time is in seconds, so it's pounds seconds of input. In the SI system, it's going to be newtons times seconds. Now, a key thing to understand about impulses is impulses are required to change motion. Because in order to change the motion of anything, I need a force, and the force has to act over some time. So that's kind of one of the key things about it. In the old Star Trek show, they used to talk about an impulse engine and a warp engine, and the impulse engine was the one just used to kind of fly around just from like planet to planet. If you wanted to warp, that's when you were going across galaxies and stuff like that. So force times time is equal to that. And that's kind of important. Now, force times time will change momentum. So in other words, if I have that, I'm going to change momentum, which makes sense because it's going to cause me to change velocity. And that's kind of our definition of that. So Ft is equal to delta P, and that's in the linear world. Now, and again, so that's straight line motion. That's crashes, car crashes, things like that, hitting a baseball. We talked some about safety stuff. Safety, quite often, what we're trying to do is delta P is going to be the same if you use brakes or if you hit a tree. The difference is here with the brakes, T is long, so F is short. With the tree, T is short, so F is big. Don't hit trees. All the safety features in your car are really designed to increase the time it takes your body to stop. Now, the flip side of that in athletics is the reason for follow-through in almost all sports, tennis, baseball, softball, golf, things like that, is to increase time. If you increase time, then what's going to happen is you want as big a force as possible. You get that from working out. So then you get Ft is equal to delta P. And of course, if you're trying to follow through, if you increase time and increase force, time to go to class, what you're going to get then is the largest change in momentum. Now, real quick, let's talk about angular momentum. It's the same concept, angular impulse. It's the same concept. If you're going to have something rotate, what's the force-like quantity that makes things rotate? Wait for it. Tell me. Think about it. It's torque. So torque times time is equal to the change in angular momentum. So that's going to cause things to spin faster. And we have a lab we're going to do on that next time I see you.